Hey guys, welcome back to AlgoYogi. We are doing tree series right now, and our next problem in the list is House Robber 3. Let's go to the problem on LeetCode. The thief has found himself a new place for his thievery again. There is only one entrance to this area called root. So it's a tree problem. We are starting to solve our problem at root. Think it like that. Besides the root, each house, which means we're talking about nodes, has one and only one parent house. All right. So after a tour, the smart thief realized that all houses in this place form a binary tree. We figured that out like way before the thief. But anyway, it will automatically contact the police if two directly linked houses were broken into on the same night. So basically, the thief is gonna steal stuff, but he cannot, or she cannot, gender equality, they cannot steal from two connected houses. That means what? If I'm choosing root, I cannot choose any of its children, neither left nor right. If I'm not choosing root, I have the choice of choosing left and right, either one of them or both of them, depending on the situation. It might happen that I might not want to choose it. Like right now, you're thinking that if you're not choosing root, you might want to choose it, but think it. Those two nodes, left and right, are also connected to further nodes. And if I choose those, I might skip a chance to choose further connected nodes with higher values. Because our target here is to return the maximum amount of money the thief can rob without alerting the police. Okay, so let's try to understand how we're going to solve this problem. So far, you must have already realized that we're going to use DFS, and it's all about how are we going to return the values based on if we are choosing the root value or we are not choosing the root value. So let's take the first example. Let me make the tree over here, this is a simple example, so it should be easy for us to drive the solution. Now, let's say, should I choose root or not? But what I'm going to have is basically return two values. One is I'm choosing the root, and the second one is I'm not choosing the root. So that's what I'm going to return. So let's have it, call those variables with root or without root. All right, so that's how we're going to return our answer. But since it's a DFS call, just think it simply that we're going to keep calling until we reach a leaf node. So we're going to keep, let's say we're going for a in order or like post order or whatsoever. So let's keep going to left. We come over here there is no node, so that means what? With or without, it's going to return 0 and 0. But then it's going to call over here. This is also going to call 0, 0. Then it comes over here. And now we have a choice of either selecting this or not selecting this. So what's going to happen is we're going to return two values. One is choosing it. Other one is not choosing it. Right? Now at this point, at 2, what I'm going to have, again, choose two values. One is I'm choosing it. So if I'm choosing it, that means what? I cannot select anything from here, and I cannot select anything from here. And that is like 3, given that they do not have any other nodes here. But then I'm going to choose basically 2. And if I'm not choosing 2, that means I'm selecting the maximum value from either of these sides. Because I am not choosing 2, that means I could select, I have to return the maximum value from either of these sides. one is choosing it, another one is not choosing it. So I can choose any of the maximum values. So I can just basically, maximum value would be 3 from here. Now the same thing will happen over here. This will basically be 1 and 0, and then over here it's receive 0 0 from here, and then at 3 I have the choice of choosing 3 or not choosing 3 but choosing the maximum from here. And then finally when I reach 3, then I have a choice of choosing 3, but at the same time, because this time, like, it's the value with root, so that is 3. But at the same time, if I go down, because we had further nodes down here, since when I was not selecting 2, then also I had 3, and when I was not selecting 3, I had 1. So that means what? I'm going to join these two values, 3 and 1, 4, and place them over when I'm choosing 3. Okay, because that time I'm not choosing these two values, I'm not choosing. So whatever came from bottom, that could be collected and added to my answer when I'm choosing 3. But when I'm not choosing 3, that means I can select maximum from choosing this value and choosing this value. So basically 2 and 3, and that would be 5. However, we know the answer would be 7 with choosing the root. All right, quite really simple, easy to follow. When you'll see the code, it's going to be like the easiest of the easy problems. Okay, let's switch our view to coding window. So we're going to have a DFS function that's going to take root, and that we'll have to check the base case. If root is none, that means what? We just return 0 0. Why? With root, without root, it's just we're returning 0. So let's process the left side. That will be just easy DFS on root.left. Let's process right. Easy DFS, not DFS, DFS root.right and root.left and root.right. Then what? Also remember, we were returning what? With and without. So let's say with root and without root. These are the values we have to basically form or derive using the left and right. So first let's work on with root. With root meaning that I'm going to consider my root val, and then I'm going to add, because this time I'm choosing it, then to both my children left and right, I'm going to consider the first value, so that like at index first, because those values came without choosing those left and right nodes. So I can definitely choose those values, right? The value that I can't choose is the first one, because it includes those particular nodes, and I have to skip, otherwise I'll get caught by the police. Okay, so it will be left and value at the first index, and right value at first index. Okay, easy peasy. Now that's with root. What's without root? Now this one is tricky. So without root would be, I'm not adding root value, but I can select basically the maximum. If I'm not choosing root, then I can choose any maximum value from those two values in each of the sides. So maximum from left and maximum from right. Why? Because when I'm not choosing root, that means I have the freedom to basically consider below values or not consider them. I don't know. There could be a maximum value without considering those two nodes, and there could be a value, maximum value, considering those nodes or without considering those nodes. I cannot choose, like, I cannot add them all of them up, but I can choose the maximum from left and right. All right, and that's it. We can finally return DFS on root, but remember, this will give us two values. What we're going to return is maximum of those values. Just like we saw it this example, we were seeing 7 and 5, and we were supposed to return 7 because that's the maximum value we could steal. And stealing is a bad thing. Don't do it. All right, let's zoom out and run our answer. Passes the test cases. Let's submit it. All right, 88%, quite efficient. All right, let's write the time complexity. Time complexity is basically we're visiting each node once. I don't think we're visiting any node even twice, because we're just visiting the node, calculating the value, returning back to the parent. Okay, all right, so it's going to be big of n. N is the number of nodes, and space complexity is also big of n. Let's call it maybe h, which could be equal to n. All right, this is it. We have done a wonderful problem. Let's go back to AlgoYogi, make use of it. It's only going to help you guys. All right, let's mark it done, and ta-da. See you guys in next problem. Until then, bye-bye.